Hello everyone. I hope you're enjoying the weekend as I do. This is my 9 live stream, I think. And today the goal is to at least build something, to showcase initial stages of Rust query modules development. So in my first part of Rust related live streams, I've just initialized the initial query module and managed to run an example, but it was an empty example. And then I do a bunch of then I research a bunch of stuff through the available tutorial on the internet. But this time, like today, this week, I've managed to build an example of the actual module, and which is doing something, which is returning some results. And also, I've added initial stages of the library development, so initial abstractions to dealing with the data. With the data from Memgraph. Actually, the step before, just registering and dealing with the procedure-related constructs. And yeah, I did the work. I'll just go through that and explain. There are some nice things from the Rust. Like I was surprised how many things I actually used from the tutorial. So that was very good. And yeah, that's more or less it. I think I'm gonna be super quick today. For sure, less than an hour. And yeah, please like, share, subscribe if you find this interesting. And yeah, let's dive in. So I'll sorry, wrong button. So this is the major repository and the branch related to the query modules. And I'm actually on the wrong branch, on the wrong commit. So I did this 2 weeks ago, add initial hacked but working example, and now we have an example that is returning something, and an example, a more rusty example that is using Rust related code. And I mean, whoever is implementing a query module won't be able to work in the unsafe environment. So we removed unsafe code and abstract it. So let me first so I did this here. Let me first check out the hacked example just to remember what was that. So here we have the test procedure, which is a C procedure, C-like procedure that is empty, and we just in the MGP init module we just register that test procedure so that Memgraph can run. So Memgraph will call MGP init module for each loaded module, and within that function we're gonna register a procedure, in this case test procedure, and that's basically it. So this is just an empty procedure that does nothing. And then what we actually did, so the MGP init module stayed more or less the same, but in addition to registering procedure, we also register a parameter or argument that can be passed. So we have a parameter A, which can be passed into the not a parameter. So this is a result type. So we have to register a result type and the name. So that will be returned in a table format from when the procedure is executed. And then the test procedure has a little bit more stuff here. So we are calling in the unsafe block, we are calling a new record that will create a record where the data can be added. So for each returning type, there can be added, the value can be added into the record, and then the record is returned, so that Memgraph engine can then return that record to the client. And here is just the basic code. So creating the record, checking if the record is null, then there was an error, so we were unable to create the record. Then we create value and store 0, so it's hard-coded 0 value here. And here we have interesting. Here is the first bit of a Rust abstraction. So MGValue is actually a Rust struct that has a pointer to the MGPValue object, and then this is a bit. I'll come to this bit later. But MGValue is created here. Then we check if MGValue is a valid, is not null, or if it's null, then we have to create an error, set the error, and then return. And then at the end, we are inserting that value into the record, and that's it. So and then sorry, record value. Yeah, and then it's inserted. The value is inserted into the record, but record is a part of the result, so, and that will be returned. And also we set an error here. All right, and let's now go here. So MGValue has a drop trait implemented, and basically that's called whenever an object goes out of scope. And in this case, we initialized the value object, but we are also responsible for deleting that object within the procedure. Since once we insert the value into the record, we don't need that memory anymore. And that drop implementation will just call destructor of the value object. And that's going to happen at the end of the scope here. So let's say here, that's the end of the scope. And at that point, the MGPValue is going to be actually deleted. So yeah, we're going to have abstractions in the Rust query module. There will be abstractions for all objects inside Memgraph, but we'll just have pointers to all of them. So some pointers we don't own, but some we do. We have to deallocate them. But the good thing is, with Rust, we'll be able to implement these abstractions that will automatically delete whatever we allocate. So a Rust query modules library will have the code to deal with allocations and deallocations. And that's basically it. So this procedure here should return 0 as in the A, let's say, record, or how to call that. So let's test that out. So here I also prepared a Docker command that is loading all of that, but I have to actually compile that before cargo build. So we hopefully build this now, and let's run it. So here we have the loaded module, libtest rs query module, and then let's go here, maybe a little bit before that, just to verify. So in the lab we have that procedure registered, so everything was successful, and then we can call that and the call was successful. So A is returned, like single value of A is returned, which is 0. And that's what we did there. So we are actually having the right thing executed. So let's go back here just to show the drop part. So just to be sure if that's executed, we can do here macro print ln macro, which says destroy a value, and let's say okay, let's recompile. So yeah, I'll just reload every single time, just because it's simpler. So if we run this now, it says value destroyed, destroy value, value destroyed. So that's called exactly once per call of the test procedure. And yeah, let's run it again. So again, the same thing. So we allocate and deallocate that value. Okay. Oh, let's go back. This is what we don't need. I just wanted to prove that it's working. And that's it, I believe, on this side. One note here. So we have all these strings because like we have to create all these messages, and the problem is the C string is the, let's say, null terminated C string which can be used from Rust, and we have to allocate that object. So that object is created on heap, and the memory for that is allocated on the heap, and I think Rust is taking care of destroying this at the end of the scope, so that's all fine. The problem is the expect is going to panic, and in the future videos, I actually didn't do that. In the future videos, we should remove this part here and not crashing entire thing if we can't allocate that string, because then Memgraph will also be crashed. I mean, Memgraph is going to crash if this module is also crashed. So we have to ensure that that doesn't happen, but that's for the later videos. And this, one more thing is that so I have all these variables, all these strings predefined here, because that's I saw in the Rust documentation. So whenever you have like the unsafe block, then unsafe block is at the end of the function, let's say, and all these non-safe, all these safe things that have to be allocated or something are placed at the beginning of the procedure. So that's just a convention that I saw in the Rust documentation. So yeah, that's about it. And what else is important here? So yeah, the unsafe block is here because we are calling a bunch of these MGP procedures from C, and it whenever there is a C call, unsafe block is required to exist. So we need to have that here. But since we are now in Rust and we are able to implement these safe abstractions, the next goal is to delete these unsafe blocks from the user code. So whoever is implementing a procedure or anything on that side shouldn't doing any unsafe code. So the whole code should be safe, and Rust should be able to to check all the type safeties and all these things. So in the next step, the goal is to remove these unsafe blocks from the user code. And I actually did that. So I'm going to check out the last version of this code, just to compile it, not to forget that. And at this point, it starts being interesting. So I'll go through this code. Yeah, maybe we'll go from the end, actually, top down. So in the MGP init module, now we don't have any unsafe code. So we have we called add read procedure, and that's a procedure function that we actually implemented in the library part. So I have the whole library part here, and that procedure actually has unsafe code. In the unsafe block, we call MGP module add read procedure as previously, and we add the procedure pointer to that module. So module is MGP module. Module is so module is here, MGP module, and name is the name of that procedure, of that read procedure. We just pass a string. I believe there are other options here. I can probably send borrowed string or something else, but I didn't play with that. I'll add that. I'll play with that later for the future videos. But string is the Rust string that is passed here, and then since we need C, like we need null terminated C string in the query modules, we still have to create that C string, but here we just passing bytes of that string here. And then the same, expect turning that into a row pointer, and we are adding here the procedure pointer. The interesting stuff here is that we just add here as a type extern-c function that has these 4 parameters, and that actually works. So I was a bit surprised how easy it is to add these types. So we just copied exactly the same function signature, and it works. So it just works. Okay, and then that's the read procedure, and we get back the actual procedure. So now here we have the actual MGP procedure pointer, and that pointer is then, so add read procedure. So here we have the mutable pointer to MGP procedure. It has to be mutable because the procedure is we add return types in the actual procedure. So we return that as a type, and then we just call another function, add result type now, which gets the procedure, which gets the name of the result type. So that's the A. That's the from the result. That's this A here, and yeah, that's fine now. And then if the result was okay, so match is just calling, so add result type. When that's called, it actually returns the result. The result can be okay, in this case nothing, or an error. An error has the exact type, and then we check for that. If everything is okay, we just return 0. If there is an error, we return 1 from this function. And that's basically it. We have after this point, we registered the procedure inside this module. Maybe to get here, what is happening here, we are accepting a procedure, pointer to procedure, and the name again. And the result is okay of nothing. And we actually defined the parameter type error, which is the concrete type for error returned from this function. In the actual implementation, we again have unsafe code, and then we add a result to procedure. Again, the same pattern. We have the name, we transform that into bytes, and pass that to the add result function. And also we I actually have a problem here, since that's not correct. Add int result type. So yeah, this function is specific because it adds an integer as a result type. So yeah, this has to be changed. Yeah, I'll just do this now, but I'm sure in the future I will change that with an enum or something that will have all these types listed, and then the add result type function will just get that, the concrete enum type, and that will be handled inside the implementation. But for now, let's just be consistent with here. Let's just be correct here, actually. And yeah, if this is also a bug. So if MGP procedure add is null, is 0, then it's an error. So I think that's in our, so add result. 0 is returned if unable to allocate memory for our result field. So yeah, that's correct. Let me I added a couple of changes here. So I'll just rerun to be sure that everything is working. Yeah, it's fine. All right, and I also use cargo format. Great. Okay, that's it. Let's go back. So we have add int result type. Great. But then we have the test procedure implementation. So instead of having complex stuff here, we just have a nice Rust code. And since I'm not expert in Rust, I wouldn't claim this is actually nice, because it has these match statements nested. I'm sure there is some pattern to deal with that in a better way, but anyway, I think this code is correct. So let's leave it like that. I'll try to figure that out later. Yeah, since we have like match, and then we check all we have to do the error check after each call of function. I mean, that's what you should do, but in general, I think there is a better way to do this type of things. Okay, and then we call make result record inside the result. And that's also our function. I'll explain it a bit later, but it just returns MGP record. So we create a record and then we return it here because we have to add some value into that record. And yeah, we have that MGP record here, and then we have to create the value object and put some data inside. And here we added 0. These are just requirements because we need the memory pool to allocate memory space for the data, and also we need the result to add that into the result. I think we need that here. So no, sorry, we need the result because of if some error occurs, then we need to update the result object. So that's the actual reason. So that's here. That's done here. Let's go back a bit. And once the value is added, then we actually have insert result record. So we add that value into MGP record. So let me just check this method here. So yeah, we are inserting value to the record. So we are calling here MGP result record insert, and that's again the same pattern. So we allocate these strings, C strings, at the front, at initial part of the procedure of the function, and we have unsafe block to call C API functions. Let's go back. Again, match insert result record. If it's fine, we do nothing. If error, we return. Basically, I think in this case we are okay with just doing nothing, but in general we should return in case of an error, because there is, if error occurred, a function added an error string into the result. So the result Memgraph engine will pick up the result and return it to the user. And that's it. So that's the basic pattern. And then we have, this is here actually the end of the library part, but let's go to the front. We have a couple of errors. So we have allocation error that happens if we have to allocate some memory, and then the allocation fails. That has to be returned to the user. And yeah, in Rust we don't have exceptions. We just return error result, and these are structs to return it. And that's fine. So it's actually fast, and it forces you to do the error checking, which is always a good idea, because if you don't do that upfront, then later down the road you will somewhere have a headaches of dealing with memory related problems, with errors in general, and figuring out from which they are coming from. Okay, we have allocation error, we have preparing result error, and we have add procedure parameter type error. I've just created these on the fly now because I needed some values. I'll think how to properly call them and have some consistent way of naming things. But yeah, here the only interesting thing is that we implement standard format display trait to actually show, like, to print these values in a user readable format. But that's basically it. So it just write that string here, and that's it. Apart from that, we have MGPValue. In the previous commit, I call that MGValue, but I decided to MGP because it's more consistent and more specific. So yeah, MGPValue has the value, which is pointer to the actual value, and it implements drop trait because it has to be deallocated. That's I think clear now. And then we have MakingValue. MakingValue is just calling C API function, and it returns the pointer to the actual value. And yeah, here we have the integer value because we just we have to be actually specific. So MGPValue make integer. That method has that name because it's only useful to make integers, and we just proxy that here. Previously, I said that we'll have these adding result types with enum. Here, it's a bit more tricky to do that because we have different types here, but I think it should be possible by doing templates or something similar. I'll definitely try that at some point. Integer is okay, and then also in addition to the simple value, we also have a result record struct. So it has, like, result has many records, and then each record has many values. But we also need to have a pointer to the actual record, since we're adding value to that record, and we have a struct for that as well. And then that struct is returned from MakeResultRecord function, and again the same pattern. So we just allocate C string. These are all error strings that Memgraph will eventually return to the user, and we have unsafe block to call the C API functions here. And that's it. At the end of that function, we create MGP result record object. If you remember from the tutorial, it's created in this way. So there is the MGP result record, and then that dictionary-like syntax to initialize the actual value. So under the field record, the record will be stored. And then we have the insert result record. So once we create a record, we have to insert that record into the result, and this method is doing that. Again, the same pattern as before. Add read procedure, okay. That's what we already explained. Okay, let's change things a bit, just to prove that we have the valid implementation. Let's say we'll add one more result type, or how to call that. So we have A, and we will add B. That's fine, but now we can't do this because that will return on the initial result. We're gonna just return 0 here, and that should work as well. I mean, at least that should compile. Yep. Okay, but we did not create any B record. So I'll just copy this. So we have to do all that because of all these things. So I think it makes sense to implement some abstraction for this as well. But for the B value, we'll actually add, I don't know, 100 here. So now we added the B value. Let's compile this. Yeah, okay. Let's reload. If we run this, boom, did not yield all fields as required by its signature. Okay. That's a nice error message, but it's a problematic one. Aha. No, I'm stupid. Sorry. We don't need another record because we already have one. Sorry. We need a value. MGP value. Okay, we add that. Okay, does nothing. If record is fine, we do match, but we have to add a block here that this is related to here, and we did this here. Okay, now we have the block, and now we need two match statements. Yep, but this is wrong. So match here, and I think we need another match integer value like this. Uh, 100 here and B. And now this we return only in the case of error, which is fine. Let's build this. Boom, it works. Okay. If I reload, nice. Great. So yeah, it works now. So we have A and B and 0 and 100. That was successful. And maybe just to finish, to add more stuff here, let's do some loop or something. I'm actually not sure what's the actual syntax for running this. So for loop Rust, let's quickly get this. Yeah. X in yeah, okay. So, and this time we need more records. So for index in 1 to 10, that will and yeah, I promise for the next live stream I'm going to add the formatting automatically in Vim, so that I don't do this crazy wrong stuff by typing the format related stuff. So okay, let's say we have, I don't know, now instead of passing 0, we should pass index and again index times 100. I think this is going to work because integer is here, so it has a copy trait and clone implemented, so we will not have issues with borrowing and similar stuff. Okay, maybe just to format this, yeah, to have a little bit nicer. Okay, if I reload and run, boom. Okay, so now we have AB and we have multiple values for that, for all of them. And yeah, maybe just to do what we did before about allocations. Delete cold cargo build reload. If we run now, we should get the same result, but we have delete cold once 20 times because we have 20 values created. This is a bit unoptimal, but yeah, that's to optimize for later. we'll just delete this. Yeah, I think that's more or less it. So what did I change here? So I've changed the integer result type. Yeah, that will change in the future for sure, but let's leave it like that. I remove that not here, which was wrong, and I added more data here and also added additional result types here. Yeah, that's about it. So I'll just commit this super quickly. No, I'll leave that for later. Okay, any questions? Yeah, if you have any questions, please put them in the chat. I'll just commit that either way. Okay. Yeah. Okay. Let's go back here. I think we're done for now, for today. This was super quick compared to my my previous videos. But yeah, I think it. I hope it was good. Next week, next weekend, next Saturday, I do more stuff. So hopefully throughout the week I'll be able to build more of these abstractions and actually have something which should be used, or I don't know, maybe should be used to build these Rust modules effectively. That's it. So have a great rest of the weekend. Please subscribe and share if you like the content here, and yeah, enjoy. Bye bye.